Welcome back to your channel QERT. So we are continuing our Spark optimization technique video series, and today we are going to discuss about AQE, that is adaptive query execution. So last day, while discussing catalyst optimization, we discussed about rule-based optimization, cost-based optimization. Along with that, we had discussed a point that is AQE, adaptive query execution in the catalyst optimization. Now we are going to discuss that topic in brief. So what is AQE? Remember, we give an example on that video that suppose you are planning to go home from office and you are booking a car or rapido maybe to go home. Now you started your journey and in the middle you find some roadblock or something. Now while riding itself you have to find out another way to go home. Okay, so it is AQE, it's like that. So while processing our job, while running our application in Spark, so suppose what kind of difficulties and challenges in there based on the statistic, if our Spark find out, it will do adaptive query execution, and that is finding out a way out of that. We'll discuss about that. Before that, I am Ganesh. I have completed my master's in data science. I am Apache Spark certified by Databricks, also a Databricks certified data engineer. 9 plus years of experience in data engineering, also Snowflake certified. So that's about me. Let's move on. So AQE, classic Spark, plan chosen before execution. So what classic Spark do? They choose the plan before execution. AQE re-optimize during execution using runtime stats from completed stages. Key features: coalesce shuffle partitions, skewed joint handling, and joint strategy switching. We'll discuss this. So before that, let's get a brief idea about adaptive query execution. In my screen in the left hand side, you are seeing static plan, that is classic Spark before Spark 3.0, and right hand side screen you are seeing adaptive query execution, that is after 3.0 Spark version. So classic Spark, what it does, I mean, it's get the query, optimize it, and execute it. Okay, so uh, as I was giving the example at the beginning itself. So classic Spark, how it will do, it will plan your journey to home from office. It will start right. It will find out the best way to go home, and you will reach home. It is doesn't bother how long it will take again, if you faced any roadblock or something. But let's discuss about the AQE. So suppose you started your journey to home from office. Now is you are riding the bike and in the middle you found some roadblock or some bridge breakdown. Then what you will do? Then AQE, I mean, you will find another way, the more faster way to reach the home, the next more faster way to reach the home, right? AQE is like that. While running the Spark job, it will parse, then optimize and execute. But in AQE, it will parse and start executing. And while executing based on the statistics, I mean, how it is running and what is happening inside, how it can do better. So it will find out those things. Okay, how uh, how Spark can run more faster or use less resources, then it will re-optimize it and execute it again. So yeah, that's the thing. Then we'll going to discuss about the ways AQV will help us while running the Spark job. So first, skewed joint handling. So as we have learned that Spark create partitions while doing the shuffling, and while doing the transformation lots of partition gets created, and it can create different size of partitions. Suppose for example, uh, one partition is suppose 5 GB, another partition is 10 MB, like that. Okay, so split oversize partition into multiple tasks to remove strugglers. Key: skewed partition factor 10, skewed partition threshold in bytes. So using the key, you can specify to Spark if these scenarios happen, you can do repartition. I mean using the coalesce. So here in the example, you can see in the screen. So suppose you have these partitions. I mean, in the left side of screen, you can see there is a different size of partition, but among them, one partition which is in red, that is very large. Okay, large amount of data. So how AQE can help us? AQE will break down this partition into maybe one more partition. Okay, that's why you will not have any skewed partition. And we know how skewed partition or skewed data can make our job very difficult. So by dividing that big partition into two small partition maybe, or if required maybe three, as per the requirement that Spark will decide, it will divide that. And in the right side screen you can see how it resolved the issue. Now every partition is kind of has the average data to proceed further. So yeah, this is the first option. AQE detects skewed partition and split them to remove stragglers. Next is coalesce supple partition. So what happened? Merge tiny post shuffle partitions, fewer tasks and less overheads. Below is the technique which you can use to indicate Spark which type of tuning it need to do. So tune advisory partition size byte 128 to 256 MB. So it will. So what is this actually? Let's discuss a bit more. Suppose you are doing supple partitions. I mean, while doing transformation, supple partitions happen while doing the white transformation. So while that happen, it create too many. It can create too many little bit. I mean, tiny partitions. I mean, maybe here in the example you can see 10K tiny partition got created while doing after doing the white transformation. Okay, then AQV use coalescing. Then AQV AQV will collect those tiny partitions and merge them into small partitions. Like the size will be maybe 128 to 256 MB, that is recommended. And you had previously 10K tiny partition, now you have 200 to 600 small partitions. So that's how it will merge. And why it need to do that? Because as we have learned earlier in this video, that reading or using too many tiny partition or tiny files or tiny data can be difficult while processing with Spark. I mean, it create metadata overhead. I mean, suppose you are opening too many small, tiny books and reading it, and the other hand, you have one large book which you are reading. So which one will be the easier? So opening a file, reading that, uh, I mean, if that is 10,000 K, that can be difficult process. Instead of that, 200 to 600 partition with the average size of 128 to 256 MB can be easier for Spark. It will reduce the metadata overhead. Okay, moving on. Another way, and very important, is joining strategy switching. If build site small at runtime, broadcast has joined, else sort merge. Keep auto broadcast join threshold to 50 to 200 MB. So let's discuss what is this. So what we do basically is, sometime what happened, we did not mention the broadcast join even when we have the one dataset small and another is large. Suppose you have a dimension table which is under 100 MB, 50 to 100 MB, or 10 to 100 MB. Okay, and you have other hand one fact table which is in 10 GB, 20 GB. Okay, so you need to match those. I mean, join those, and you are writing the code and you are just doing just simple join, sort merge join. Okay, now what will happen, sort merge join is basically for two large data set if you want to join them, but you are using a small data set which is around 60 to 100 MB, and another is around 10 to 20 GB, suppose for example, but you are still using that sort merge join. In that case, while pausing, while running the job itself, Spark will find out using adaptive query execution. It will find out that you have a data set which is only 100 MB. Okay, within 100 MB. So that will then it will decide that yes, we have a small data set. Now we can do the broadcast join. Now it will join two dataset using broadcast join. It will broadcast the dataset to every executor and do the broadcast join. That way it will be more faster. So always it will not be in your mistake. Suppose you are seeing a too big dataset, right? But one dataset you will do some filter before before joining that. You have not noticed that, but you are doing some filter. So while Spark optimize that, Spark will notice that you are using a filter in a data set. After doing the filter, the data is coming around 10 to 100 MB. So then Spark do the filter first, and when the small file will come, it will broadcast that one. That way also it can happen. And remember, by default broadcast joint size is 10 MB. You can increase that if you have good amount of resources. You can increase that to 100 or 200 MB, but it is not recommended to go beyond that. Yeah, that's how it can help us. So it was all about the AQV adaptive query execution. I was planning to prepare this video for a long time. I did not get time. I'm sorry for that. But yeah, this is a big achievement from the point of view of Spark. While running the job, you now it can optimize our job. So that's it for the video. Thank you so much.